So this is generally an intro. This is kind of very high level, skimming across a selection of tools, explaining how I use them and how they fit together. So if you're expecting a super deep dive and to learn exactly how to use these tools, that's not what this session is. If you want to get a flavor and get context and kind of know what you should then go and learn next, you're in the right place. Sound good? Good. All right. Ready to go? Let's go. Hi. My name's Simon Whiteley. Hi. And yeah, this is a data engineer's ETL toolkit. The various bits and pieces that come together for me to do data engineering, for me to get data to the right people, and it's largely focused on Azure. So how I'm doing that in the Microsoft Cloud, and why Ssis is not necessarily the right thing. Normal stuff, housekeeping, please silence cell phones because you're on TV. You don't want to be that guy. Pass does lots of things. We all like Pass, that's why we're all here. Me. So I'm a director of engineering. That's a fancy title. There's only 2 of us in the company, so we had to pick fancy titles. I run a consultancy in the UK, essentially doing this kind of stuff, helping people with their data engineering problems, advancing analytics, helping people productionize machine learning models, helping people get data from A to B. And I spend a lot of my time helping people go from on-prem, old world ways of thinking to how do we adapt? How do we become agile? How do we react faster? How do we meet the needs that people actually sort of have these days? So that's me. Grab me on Twitter. Happy to answer any questions, all of that stuff. More housekeeping. The Microsoft Certs team. So there is a data engineering certification. And if you're interested in that, the guys have been running workshops, Q&As, that kind of thing. So I think you missed today's one. So tomorrow, 12:45, and again, kind of another one tomorrow. So if you're interested in that cert, look out for those guys. Go say hello to them, room 204, and you can kind of learn a bit more about what's on that certification, how you onboard, and all of that stuff. OK, so this is what I'm going to talk about. What is a data engineer? And this is very opinionated. There isn't an official definition. But I'm going to explain kind of how it fits in context in my head, kind of the lineage, where did it come from, and the challenges of the way a lot of people currently do things, and why it's changing, and kind of what's bad about it, essentially. Not going to hate on SSIS too much, don't worry, just a tiny bit. Then looking at the new tools, we're going to look at Data Factory, we're going to look at Databricks, we're going to have a look at Logic Apps. Logic Apps always comes up, everyone's like, isn't Logic Apps that? And I'll show you where that fits in. And then circle back into Data Factory and have a look at this new thing, mapping data flows, which is now GA. You can now use it. I'll show you what it is, how it fits in. And then the big bit at the end, give you that context of how it all fits together. If you're building a solution, you might use all of these tools to actually achieve that whole solution. So I'm trying to get you into the mindset of how it all fits together. Sound like a plan? Still awake? Yes, good. OK, so what is data engineering? It's a massive question. And for me, it's a combination of 3 things. So we've got the traditional BI developer. And it's the person supporting them. It's the person getting the data to them. And it might be them, they themselves. Essentially, the ETL developer. The person building SSIS pipelines. The person getting data from A to B into facts and dimensions and shaped properly. It's the person supporting the data scientist. And actually, data engineering, it's a term that evolved with data science. Normally, the big data engineer, the person writing Scala jobs in Spark to support the data scientist, that's kind of where the term first cropped up, this data engineer. And then there's the software engineer, the person actually doing app dev, and the person actually looking after the database for them and getting the data into it. And all 3 of those are relying on this idea of this data engineer. So it's kind of like a multifaceted thing. There's a lot of customers that the data engineer has to get data to. And unfortunately, that also means there's a lot of assumptions about what they're going to do. So from the BI point of view, it's just an ETL developer who wanted a fancy title. And I do get that quite a lot. From the software engineering point, it's like, it's me, but it's me if I happen to do some data. And data scientists just see it as a cog in the process. It's a small piece of actually, it just belongs to data science. It's a part of their puzzle. It's not serving these other people. And because of those conflicting demands, it's why we don't really have a good definition for it. It's why, if you ask 3 different people what a data engineer is, they'll give you slightly different answers. So at least with the Microsoft Cert, we're starting to get this is the tool set, this is the skills, this is what we're expecting. So in terms of, for me, for those different people asking, the BI developer is coming in saying, you need to know warehousing. You need to understand slightly changing dimensions. You need to understand how to do junk dimensions and all of that kind of stuff. You need to know Kimball. You need to know data quality. You need to understand how to make an audit event fact for the proper Kimbalites out there. And the data scientist, or software engineer, doesn't care about any of that. So they're more focused on, actually, you should be doing good architectural design. You should be avoiding the monolith and using microservices and loose coupling. There's all these kind of ideas coming from software engineering that are just expected. You should be a good developer. And traditionally, a lot of the ways that BI grew up, those kind of app dev principles didn't really get involved. I speak to a lot of people, and I say, what do you mean, you're a developer? And they're like, I'm not a developer. I'm an SSIS person. I'm like, yeah, you're a developer. But the two never quite meet. And then data scientists, they've got an entire different perception. That's more about ML engineering. It's productionizing their models. It's building efficient pipelines to deliver one specific data set into a model. So you're not worried about building a catch-all star schema that can answer 80% of the world's questions. You're delivering a particular data set. And so because of that, there's this driver, there's this confusion across all of these different things. And that's what we're trying to meet. And that's why the world has become slightly more complicated for the data engineer, because there's a lot more expectations. There's a lot of stuff that we're trying to achieve. So, long running SSIS packages, because SSIS doesn't scale. So, basically, why I kind of want to break the reliance on SSIS a little bit. Just kind of want to talk through, because of that new world, because of those expectations on me, because of people wanting me to be a software engineer and be agile and be reactive and be able to quickly react to changes, how that balances against what we currently have as SSIS. So, the old world, the way that we always did things, this pattern. Essentially, I'm going to get data from somewhere. It could be from a relational source system, my OLTP system. It could be CSVs, it could be anything. I'm going to dump that into my warehouse. I'm going to land it into a staging table. I'm going to pick it back up, do some cleaning, some quality, some validation, and put it back down. I'm going to pick it back up. I'm going to turn it into facts and dimensions. I'm going to shape it. Then I'm going to land it into my star schema. And SSIS is that tool. Each of those hops, I'm picking it up into SSIS and pushing it through. Familiar pattern? That sound right? OK, good. And then orchestrating all that, managing all that, I usually have something like this. The SSIS master package, the global executor of doom. And I'll have a load of things that are staging my data, landing it into my lake in a sequence container, saying, run all of these things. Then I'll have all my dimensions. I'll have all my facts. Familiar? Yeah? OK. I'm just making sure I'm on the right page and things haven't changed in the 2 years since I last ever touched SSIS. Thank God. Weirdly, it hasn't. OK, so why am I having to change? Why am I having to challenge? So I've got a few little quotes of the kind of things the business say. I want to say the business, report consumers, people who need this data to make decisions, to actually get on with their job. The kind of things that they're coming out with. Let's see, what do people want? I need new reports. We don't have the data yet. Does that matter? And it's like, yes. My report says profit's 100, but yours says 87. Why have we got different numbers? Why have we got disagreement? I mean, that's the age-old argument for why we've got a warehouse, right? I mean, the vendor's amazing. They've managed to find a way to encode our data into image files. You guys can read that, right? Just OCR it out. Is that cool? Yeah? No? We've set up a satellite office. I mean, you don't mind just not having an ETL window, just half that, so they can have their reports live at the same time, right? Suddenly, things have to go faster. You can deal with that. No? Can you add a new step in the ETL process? We've got a new validation, so just break apart the existing schedule and just add it out. That's fairly easy to do. No? And why did it take you 3 hours to get back to me on my support process and update that report? It's not that hard. Fairly common thing. The reason why I'm gray is these kind of questions coming up and going, really? But to take that and translate that into what do they actually want? What are these people really saying? They're saying, can we reduce the development effort to onboard new data? So can we react quicker? Can I actually turn that around and say, you've got a new data set? Sure. You can now start querying it. Not, OK, our release window is in 2 months, so we can start capturing it in 2 months. Is that OK? We're saying, I want a single platform of reporting, which makes sense. That's always been the argument. I want to cope with a whole wide array of files and formats, image files, audio, various different things. I want to scale effectively to meet changing demands. If someone says, oh, no, the warehouse is corrupted, can you reload it? I don't want to have to wait a week for it to process and get all the way through. It should be built in. It should be agile, just by default. We should be building things that can react to change. We can quickly chop and change how we're working it. And we should have support built in. We should be thinking about how we go about supporting these processes. So I turned that wish list and turned it into our checklist of stuff. What are we trying to do? Low dev effort, many use cases, flexible formats, elastic scaling, agile, and supportable. Now, guess what? We're going to try and quickly benchmark SSIS against these. How do you think? Is it going to do well? No? Well, so low dev effort is an interesting one. Because actually, SSIS is fairly easy. Yes, you can get quite deep into it. You can performance tune it. You can get into the guts of it. But then, if I'm having to build a data flow for every single different data set, for me, that's high dev effort. Yeah, it's not that hard, but actually, I'm just churning out an absolute ton of data. But wait, I hear you cry, I've got my magical tool called Bimble, so I can just automatically spam out 100 or so SSIS packages, and the job's done, right? And yes, absolutely, that is really good. That has solved a problem. But for me, that's fixing a problem with Ssis. It's not actually becoming low dev effort. All of those, I've got to deploy them. I need to build big DevOps pipelines, so every time I generate a new package, I add it to source control, I push it out, I get it into my database. And that, for me, is a fair overhead. So yes, you can make it less dev effort than it used to be, but I don't call it low dev effort. Formats and use cases, sure, CSVs, SQL databases, whole variety of just data sets, I can push it in. Can I do JSON XML? Yeah, kind of. It's not that pretty, but I can. But then how well can I do things like geospatial data, the videos? How well can I stream data using SSIS? And how quickly do I then have to resort to having big C# applications, having additional ETL tools, going, SSIS is doing all my batch data, but streaming goes a different path. You know, it's kind of not that extensible to some of the more modern ways of working. And as everyone adopts the cloud, as everyone starts getting cloud software as a service, and actually our data is no longer in my own database, it's coming from an API that delivers me a changing set of file formats, I need to be able to react with that. I need to be able to ingest modern data formats. Okay, scalability. Don't worry, this is going to get a lot more positive in a bit, just bear with me. So scalability, I can run a cluster. If I really fancy paying for multiple copies of an enterprise SQL Server license, I can pay for as many as I want. And I can run lots and lots of SSIS packages in parallel. But what I can't do is for that one really, really big data set, say, actually, just use all of my compute. So it'll scale out for concurrency, but it won't scale out for execution. I end up having to build something horribly manual to partition up my data sets and send that off to different packages so that they can do it. And that's a huge amount of development for me to have something that scales. Or I have to have a bigger and bigger and bigger, more expensive server. Pay for more cores in my enterprise license. So scalability, for me, still, the answer's not there. Talking about agility. So I've got my master package of Doom. I've generated some more SSIS packages. I need to go in and add them. Maybe, yeah, I can do that through Bimble. But technically, a lot of the way people traditionally work, if you've gone in and edited that package, then you've got to test that package. So suddenly, to actually take my new small additions and get it live, get it out, actually deployed onto my production server, I need to go through a whole test cycle and make sure everything works. I mean, you can automate that, but then that's not low dev effort. That's a whole load of upfront work to get there. These are kind of the challenges people have been dealing with for years. It's kind of like Stockholm Syndrome. We all love SSIS, but this is all familiar pain. We're like, is it really abusing us? Did we know that? Supportable. So I've used Bimble. I've got hundreds and hundreds and hundreds of packages deployed. One fails. And sure, they should all be the same. They should all be identical carbon copies. But But then what's the chance of we actually generated it, and then we had to do a slight exception, and yet that one's slightly different. And how well is it documented? You know, the code footprint, a very software engineering term, the code footprint, the total amount of code I'm looking after is huge. And yeah, I auto-generated it. I didn't have to hand crank it all, but I've still got, it's actually quite hard to support because I've got this mass of different packages. So for me, if I'm doing that little audit of, is it an agile, responsive, good data engineering tool? No. OK, good. Had to get that off my chest. I'm sorry. OK, so what are the alternatives? Why are we looking at other tools now? Kind of what can we do to try and redress this balance? So I've got Data Factory, this orchestration tool, Azure only, for doing that kind of control flow side of things. For saying, run this, then run these in a loop, and then do the next thing. Data Factory is actually very good at that. We'll have a look at how that works. We've got Databricks, Spark. We've got a big, crunchy data transformation engine. So for doing mass transformations of data, we've got an engine that can do it and will scale a hell of a lot better. We've got this thing called mapping data flows. So now inside Data Factory, you've got the ability to have very, very visual things that's going to use Databricks under the hood. So if you're looking at Databricks going, oh, I've got to learn a bit of Python, I've got to actually learn how this tool works, you can drag and drop and build things that look a lot like an SSIS data flow, but scale. Shock horror. And there's a thing called logic apps. And these are like lightweight integrations. It's kind of like the Azure version of if this, then that. If something happens, do something else. If this happens, do something. You might also know it as Microsoft Flow, also now known as Power Automate, if you've happened to come across it. So again, these are the 4 things we're going to whip through and just have a, what is it? Roughly, how does it work? What's the main takeaway for it? And a super quick look at how it looks like and what to expect when you see it. OK? Good. So onwards, Data Factory. What is this thing? How does it work? So as a very, very rough primer, Data Factory does 2 different things. It's either copying data, so it's saying take data from one place, move it to another. Go to my SQL table, pull some data out, land it as a CSV table. Go to SharePoint, pull out some data. Go to Dynamics, pull out some data, and pull it down. You can talk to various different things, but generally, it's pulling data from one place into another place and not changing the data en route. Not doing transformations on that side. And that's baked into Data Factory. That's just part and parcel of it. On the flip side, it can do transformations, but by calling other things. So aside from the new thing, aside from mapping data flows, it's generally relying on other tools to do the transformation. So it can orchestrate things. So it can say, run a stored procedure, and then run a Databricks job, and then run another stored proc. So it's like layering up various different things, it's poking these other devices and saying, you do that, yeah, then you do that. It's an orchestration engine. OK, under the hood, it's all stored as JSON. So if you're doing multiple people collaborating, it's slightly better than XMLA. But still. But it's fairly familiar. You can go and have a look at what's going in there. So the kind of things we're talking about, we're saying, go and pull data from a vast array of different sources. It can read lots and lots of different data. Go to Amazon Redshift, pull data out of it. It's very good at going into things and extracting data. Then you can land it inside Azure. So all the things that you can read data from, it can't necessarily write data back to it. It's more like, give me all your data and I'll pull it into Azure. And then it can talk to lots of things. It can talk to C#, so I can do my script component type things. It can talk to on-prem databases. It can talk to my Azure SQL databases, data warehouse. It can talk to HD Insight and Databricks. Got lots and lots of connectors. If it's in Azure, Data Factory probably has a connector for it, or there's one coming. What does it look like? Should be very, very familiar to the SSIS developer. It's a sequence of activities, precedence, constraints, linking them all together. Each activity you can drill into and set the properties and set the details. You know, it's deliberately made to be accessible, to be really, really familiar if you're coming from that SSIS world. And we'll have a bit more of a look at it so you get a flavor. It's got an orchestration plane built into it. So automatically, as it's running, I've just got a monitoring plane. I can go and have a look. I can dig into the history. I can see what's actually happening under the hood. And I can get a nice shiny dashboard telling me that all my things I've ran. Mine never actually looks like that, but you know, in this case, it's a nice green circle. It's good. OK. Now, there's one slightly annoying bit of terminology that I'm going to let you know. They decided to call everything the same thing in true Microsoft fashion. So I've got a thing called an integration runtime. Now, this is the bit of compute. This is a server that sits somewhere magically behind Data Factory. So if I'm doing a data copy, if I'm saying take data from one place and put it into another one, it has to use a server somewhere. I need to pay for that compute. Now, that is completely on demand. It'll switch region depending on where I'm doing my data. So it's always going to be the most efficient place. So you've got the Azure default integration runtime, and that's just some data that sits behind Data Factory that lets me know where it's running it, that just pushes data from one place to another. To make it more confusing, I've got the SSIS integration runtime. So if I want to run SSIS packages, I can, and I can deploy it and have it sitting underneath Data Factory. So I can choose how big a server do I want. I can choose how many servers do I want. And then I need to choose which region that lives in. So unlike the default one, which is going to dynamically switch and change depending on what I'm doing, I need to say, SSIS, you're running in this region. And if you're pushing data in between Azure regions, there's an egress charge, and there's performance constraints. So make sure you choose the right place. But again, it is just SSIS. So if you don't have to get a special version of SSIS, you don't have to change anything in your local dev environment. You can just deploy it out to Azure and then orchestrate those packages using Data Factory. So you don't have to give up on it, but you can get some of the benefits and lift and shift. You don't have to go back and rewrite your entire package. You can get this as a starting point, get SSIS running inside the cloud, and then use Data Factory, use the nice points of that orchestration. Like the first step. Then there's also this thing, the self-hosted integration runtime. Now, this used to be called yet another thing called the gateway, the data management gateway, or the on-premise gateway. Forget which one's Power BI and which one's Data Factory. It's now called the self-hosted integration runtime. So if you're trying to get data into Azure, and you're talking to your InfoSec guys, and they're going, you're not poking a hole in our corporate network so you can come and get data. That's not happening. That's what the self-hosted integration runtime's for. So that sits inside your network, and that's constantly peeking out and going, is there anything for me to do? Do you want to do anything? Do you want anything? And then if Data Factory says, yes, I need to extract some data, it pushes the data out. What that means is you don't need an inbound firewall exception. You don't have to poke that hole that can get to your SQL server. So the gateway is really good. It's that nice, secure way of pushing data into the cloud and integrating with it. So if you're trying to get data into Azure, Data Factory, self-hosted integration runtime, again, snappy name, is used for that. All right? Good. OK, so let's have a quick look at Data Factory, and I'll tell you about some patterns and things that we use in there to make it go better. OK, so I'm in Azure. I've got my portal, so I've got my data wrangler here. Just going to go into one Data Factory and just have a look at some stuff. So really, really simple example. I've got a copy data activity. So I've not got a complex workflow, just got a single copy data activity, and that's looking at two data sets. So data sets underneath it. I've got one on the lake side, and I've got one on the AdventureWorks side. So a bit of Data Factory syntax. A pipeline is the same as an SSIS package. That's my workflow of stuff. Each of my different things I'm doing is an activity, so I can chain lots of activities up inside a Data Factory pipeline. And then in order to know what I'm connecting to, I've got linked services, which is my connection managers, if you want to use SSIS. So I've got various different systems that I've set up the configuration to. I've told Data Factory how to connect to them. And then I've got my data set. So data set is within that connection. Within that SQL server, data sets point to specific tables. So it's what data am I getting? It's just a bit of metadata that describes how I connect to this stuff. But I've decided to be fancy. So I've given this data set a parameter. I'm saying, actually, I'm not going to hard code you. I'm not going to point you at a specific table in SQL Server. I'm going to tell you which table each time. And so in my connection, I'm saying, actually, connect to that SQL Server, but I'm parameterizing which thing that connects to. So I can start to make things very dynamic. It doesn't have a schema, because the schema is going to change every time I run this. And on the flip side, I've got my lake. So I'm landing data into a lake, and I'm building up the folder path dynamically. So I've got two completely dynamic connections. One thing that's going to randomly, well, not randomly, it's going to pick different tables inside SQL Server, and then for the specific table it's got, it'll put that into a certain folder in my lake. And then switching over to my pipeline, again, this is more just to give you a flavor of what it can do. So if I pick up my dynamic copy, Inside that activity, it's passing that parameter down from my pipeline. So I can give my whole pipeline a parameter, and it tells that data set the parameter, tells the other data set the parameter, and I can link it together. So this whole pipeline is now, I can run this, I can reuse this one bit of logic and pass it different table names, and it will go to SQL Server, extract that table, and land it in my lake. I've suddenly just wiped out 100, 200 of my packages that I would have in SSIS. That was that data flow pulling data out. So I can then wrap that in something on top of it. So I've got something sitting here. So I'm doing a lookup. So the pipeline itself is going to go off, query the database, and say, what tables do you have? So if I got inside my lookup, it's going to go down in my settings. And it's saying, just go to Sys tables. Give me a list of tables. So if someone actually sneaks in, adds an extra table to my SQL Server, I don't even have to update anything. It's just the next time I do an extract, I'm automatically going to get all of that data. So if you talk about what's the time to insight, how long between them deploying that, changing that source system, and me at least getting it into a lake, it's the next time I run it, it'll automatically be there. So the whole idea of DevOps, the whole idea of pushing out things as quick as possible is gone. Because what's faster than automated deployments? No deployment. It just happens automatically. So this is what we're talking about with this whole mind switch of things going a lot faster. OK, so I'm just going to kick that off. We'll have a look at it later. I'll talk a quick bit about some of the patterns that we're seeing. Just try and put in context what some of those things are doing. So, one, yes, I can have SSIS in here. And so I can have a pipeline with an SSIS activity. I need two things. I mentioned that SSIS integration runtime. I need to have a server set up to actually do the compute, do the running of that SSIS package. And I also need to have a SQL DB that acts as my catalog. So if you've got those two bits set up, you can just run packages. You need to be a little bit careful, though, because that integration runtime, you get a little dial saying, how many servers do you want? Do you want 1 server, 4 servers, 8 servers? But remember, the SSIS package won't scale out automatically across them. Each individual package will only run on one of those server nodes. So only pick multiple if you're going to be running lots of things concurrently. And it's so tempting when you first start to just take your existing master package and all the child packages and deploy that and then kick that off across a cluster. Do not do that. That is bad times. Because if you've got an SSIS package and it calls child packages within that same SSIS package, it won't scale out across other nodes. It'll all run on a single one. So you might be paying a huge amount of money for 8 different SSIS servers, and it's using one. So if you do end up putting SSIS into the cloud, you do decide to use SSIS inside Data Factory, be very careful, and do the orchestration, that master package, do that in Data Factory. Make a Data Factory pipeline that calls your child pipelines, and then at least it'll scale properly across that cluster. Yeah? Good. OK, so some patterns. This is the way we used to do things. Kind of the very SSIS way. I've got 3 different files to load. I've got 3 different pipelines, and I hard code it. And because of those things that we just saw, I can do things like pass a parameter into my Data Factory and dynamically change what it's doing. Pick a different file based on what I'm doing. I can do a lookup activity. So I can tell it to go and change what it's doing. I can tell it to query a SQL Server based on the results of that, do something different. I can have config files and say, go read a config file, change my things. Kind of use, it's almost like SSIS environments. Go and check the local file, make a load of changes to what that pipeline's doing depending on the results that you get back. I can do my for each loops. So I can say, here's an array of stuff, loop through it all. And I can choose to either do it sequentially or do chunks of them in parallel. By default, I can do up to 20 things in parallel. It'll scale up to 50. And again, you can have that suddenly gives you a huge, huge amount of flexibility. And again, I can call child pipelines. So the one thing is like a bit like the child packages that we saw. So I'm just reusing logic again and again and again by pointing a for each loop on top of that child package. But I can also use common workflows. I can have error handling packages. Whenever an error happens, just go and run this same logic and just reuse that pipeline. So I can start to build reusable components. So not only am I building dynamic things, I'm building actually tools that I can repeatedly use in lots of different scenarios. It's all about thinking about actually, how do I minimize the amount of code I'm doing and just get this to be as flexible as physically possible. So that kind of pattern is the one that we saw, that data acquisition is go off to look at a SQL Server, bring back a whole list of things to do, and then just loop through and execute the same thing for each. And that's kind of like a massive game changer in terms of building out the speed that you can react to people. Okay, so a couple of different ways we can trigger these pipelines. So I can have just a time box every half hour, take that half hour chunks of thing, every day run for your current thing. I can have it run on a schedule, just saying 2 a.m., midnight. I can have an ETL window if I desperately want to tie myself to having an ETL window. But I can trigger it dynamically. I can call a REST API. I can have something happen that triggers my pipeline. I don't have to have it arbitrarily running every hour because I feel like I need that schedule. I can have, actually, something's happened, react, do that immediately. Suddenly, I've got the power to be a lot more dynamic in terms of when it's executing. And we'll go on to that with logic apps. OK, so quick recap. Data Factory is for orchestrating all of our data workflows. No matter what other tool I'm using, I'm still using Data Factory as my control plane. It's that orchestration layer. It's the best way of getting data into Azure. Unless you have like a huge, massive thing and you need to ship a hard drive to Microsoft, it's the best way of getting data into Azure. And remember to be thinking, can I parameterize this? Is there a way that I can make this dynamic? If you find yourself copying and pasting and you've got hundreds and hundreds of pipelines, go, oh, am I doing this wrong? OK, so that was a lightning quick view of Data Factory. Let's just go and have a look if my pipeline actually ran. So in my monitoring plane, I should be able to see. There we go. So kicked off, it's in my time, apologies. All these different pipelines ran. And I can go and have a look and say which parameter passed it. So that was pulling out the product table. I was pulling out, again, product. Was I doing the same thing? And that's a product catalog. So it's kind of span out. It's got that list. It's executed the same package for each of them. And my guys can go in and have a look. What happened inside that execution? What was the results of it? How many rows did it copy across? I can go and have a nice view in terms of what was the actual thing. You know, the actual support process of going back and saying what happened in that run is quite nice. It's quite interactive. It's quite flexible. And we'll come back onto that a bit more with the next stuff. Yeah?
So one is saying that it can be triggered by, the pipeline can be triggered by time, right? Can it be triggered by event? For example, the file arrives.
Yeah.
Or can it be triggered by that?
Yes. So the question is, so it can be triggered by time. Can the pipeline be triggered by an event? And there's two answers to that. It has some basic functionality built into it to trigger itself. So you can have a blob trigger. When a file lands in a blob, trigger Data Factory. It's a little bit limited in terms of what it can do with that triggering. But you can trigger it from other things. And we'll come on to logic apps, which is really good for saying, an event's happened, do something. And we can use logic apps to trigger our data factory. And I'll show you how to do that. OK, so Databricks, also known as Fancy Spark. We're doing this thing called Databricks. We're using Spark. We're using a big data engine. And it comes back to our data scientists are asking us for big data engineering. And it used to be a really, really hard thing to do. Configuring Databricks used to take a long time, not Databricks, Spark. And Databricks is just making that easy. It's making the ability to write massively scalable projects really, really quick. But it can be really, really tempting to, when you're looking at this, because it's got the name a big data tool, oh, it's not for me. I don't have big data. I'm not dealing with hundreds of terabytes of data. That's a specialist tool for special people. And I disagree, massively disagree. If you've got a few hundred meg to a few gig to several terabytes of data, I still use Databricks at the core of that. And that's because of the flexibility of it, the agility of it. And I'll show you one or two things I can do with it that suddenly make everything go faster. Even if you're not using the full potential scale, you can have it scale down really small and still reap a load of benefits. So one of the tenets, the fundamental things we're using, you saw me, I was taking data from a SQL Server and landing it in a lake. It's landing it in this fancy data lake thing, which is more than just marketing spiel. So you've got this thing called HDFS. That's the Hadoop distributed file system. Essentially, it's saying, if I landed a file, it's not just going to be a single file. So I've got my CSV that's landed nicely, and actually, automatically, under the hood, it's going to chunk it up into several different chunks of data. It's a thing called file extents. And then each of those extents is going to make several copies of them distributed in different arrangements across lots of disks. So whilst to me it looks like a single file, I see a CSV sitting there, in actuality, it's held as lots of multiple copies spread across different disks. So when I query it, I can query it massively in parallel. I can be reading all of those different chunks of data via a different system at the same time, and suddenly everything goes so much faster. And again, that used to be hard. That used to require me telling it how to distribute. This is the distribution key. This is how many clusters and chunks to make. That's just done automatically. Blob storage in Azure will do that automatically for you. It is a HDFS-backed system. Azure Data Lake Store Gen 2 or Gen 1 will both do that for you. So I didn't need to worry about that. It's just, if you have a lake, lakes are fast because of that stuff. And then when we're using Spark, we're essentially using that. So we've got all data stored in this data lake thing as flat files. And then Spark is a distributed compute engine. So I've got this driver, I've got this thing in charge, this brain, and I give that a query. That then says, OK, each of you, each of my different workers, you go and look after that bit of data. You look after that bit of data. So they all actually just do their own little chunk of the processing. So I can just do lots and lots of working out in parallel. They'll each go off, query the lake, bring that data into memory on each one of those workers, each do their own bit of work, and then bring it together, aggregate it up. And that's coming from very traditional, old-school, map-reduced big data kind of stuff, but it's now been made actually really accessible for us. This kind of stuff's actually very easy to do these days. So we're talking about Databricks, talking about where do we use Databricks. Sure, for me, the most basic thing, I've got my data held in a relational database or CSVs. I'm pushing it into my database, prepping it to get it into that warehouse. Yes, I use Databricks to do that. I use it as my ETL transformation engine. But I can also use it to do geospatial. I can use it to do streaming. I can use it to actually integrate with lots and lots of different, more awkward types of data. Even working with my data scientists, I can solve one of the hardest problems in data science, which is it a chihuahua or a muffin? I can do image recognition. I can do custom vision. I can do automatic subtitling. I can actually use it to do some real-world problems, not just silly things. But it's so flexible in terms of what you can plug into it, right? Across all of these things, I can write lots of different languages. I can write in the same tool Python or Scala or R or SQL. So I can actually have a load of analysts writing SQL, and then a load of data scientists writing R and Python, and actually I don't need to switch and change and have a different tool and integrate it. Just one consistent environment. And it plugs into lots of things. So I can plug into an ML library. I can plug into Cosmos DB. I can call cognitive services and do automated ML. You have a question? Yeah. So I could have something, I could write basically a SQL statement, joining together data sets, making my dimensions. Sorry? It would, yeah, so if I'm doing it in SQL and Databricks, would it be like doing it in stored procs? Yes, except it'll scale. So you write the SQL, and it is an ANSI standard of SQL, it's not the most modern, and it will take that and turn it into a distributed query on your engine. So it's made so it feels familiar, it looks like SQL, but it's doing big, heavy Spark parallel jobs under the hood. OK, so the thing I'm going to briefly show you, I'm not going to go into the nuts and bolts of it, I've got a thing called a Jupyter Notebook, so I've got a data processing script. I've got a starting layer in my lake. So that raw layer, that first bit of my lake, where I had that data factory and it landed those CSVs in it, I'm going to take that. I'm going to apply a structure to it. I'm going to say, OK, this CSV, does that match my structure? I'm expecting it to have 5 columns and these data types. Does that actually work? And anything that matches, I'm going to put into the next stage. I'm going to store that as a Parquet file, essentially column store. I'm going to have it heavily compressed, built for analytics. And that's just my good data. And anything that's bad, I'm going to chuck out and say, there's my rejected rows. Super traditional, first part of ETL, right? Validate my data, apply data quality, check my structures. But I'm going to parameterize that, so I give that just a single data processing script, different parameters, and it will do that for different tables. So rather than having 100 different packages saying, this is how you clean that one file, this is how you clean that file, this is how you clean that file, I have one generic script which I can just parameterize and use for everything. And again, suddenly everything becomes quicker. So let's have a look at Databricks. How are we doing for time? Yeah, not too bad. OK, so this is Databricks. And again, it's one of the new fancy tools. It's entirely in Azure. So all the development you can do through Azure itself. You don't have a Visual Studio project to go and work with it necessarily. You can do a few things in here. So I've got clusters. So I can go and specify different clusters. I can say, this is my cluster that's got a couple of really small boxes in it. This is my cluster for doing the big, heavy lifting. I can have lots of different compute profiles in here. And when it's turned off, I'm not paying for it. So I can turn the small one on to do some quick jobs. I can turn the big one on only when I need to. So you can really heavily manage actually how you're doing scale. If my analysts are saying, no, it needs to be up, I need to query something, I can give them a fairly small box that I'm happy leaving turned on and not have to buy a massive server because there's a compute spike. So all the things that we used to do with SQL Server when I'm planning for that ETL workload, and because it's just like one massive spike of work, I have to buy a huge server, I don't have to do that anymore. I can have just little compute spikes, turn it on for 10 minutes, and then just turn it off, and leave another one turned on. Because the data is separate, because my data is in a lake, I've got separation of what compute I need versus what storage I need. So I gain massive amounts of flexibility here. So I've got a workspace. I've got a load of different scripts. There's a few things I can do. So apologies, a bit of Python. Give you a little bit of dip in it. So I've got a quick script. And this is saying, here's a structure. This is just hard-coded. I'm expecting to have this as a structure of something. So there's going to be a data set. It's going to have 4 fields. It's going to have an int, a string, and a string. Fairly easy. Now, normally I don't hard-code that. Normally that's going off, talking to a metadata store, going and saying, what am I expecting to get here? Just for illustration. I'm giving it a place in the lake, so I'm just pointing and saying, this is where you can find that CSV sitting in my lake. Again, normally I'd parameterize that. And then this little bit of magic, I'm saying there's a data frame. Essentially, it's kind of like having a table variable. I'm saying this is an object. It's going to have a shape. It's going to look a bit like a table. And do that by going spark.read. So use my Spark engine, go and read some data. This little switch, bad records path, is saying anything that doesn't fit that structure, actually separate that and put it out as a little bit of JSON. That is all I have to do. Make some rejected rows, record anything that doesn't work over there, and I'll take the rest of the data and carry on with it. Some really small little tweaks. And yeah, there is a little bit of a learning curve to get started with this. But for doing some really, really kind of previously quite hard to do things, there's actually some things built in which make our lives insanely easy. So to write that out, I take my data and just do of that data frame. So I'm referring to the variable I created up there, .write, .parquet, and push it out. That's a fairly simple example just to illustrate what this kind of syntax looks like. But a lot of our data processing scripts were doing that. So go get some data from here, apply some logic, apply some transformation, write the data out to there. Kind of the same as processes we're doing with SSIS, except this time it's script-based. And I can have it to be on SQL. So I quickly show you, go back to this one. I can show you, my notebooks can be quite interactive. I can have SQL queries. I can go and register data and be able to use it like I would if I was querying a SQL server, except this is over data in the lake. So it suddenly becomes, again, it's not that scary. So Databricks can do lots and lots of things. And then the other thing I need to do, if I'm working in this way, I need to be able to work with it. So this notebook at the top, I've got an input parameter. I'm expecting something to go into this notebook to tell it what to do. So I've got this little bit of code saying, add a widget. So in this notebook, you're expecting to have an input parameter. I'm going to call it file name. I want to default it to product. So if no one gives me that file name, I'm just going to give it a default variable. And then just label it as input parameter so it looks nice and accessible. Then inside my code, I can say, well, actually, I want to refer to that. Whatever value of that parameter is, I want to refer to that as file name. So actually, I can just then line up, here's what I'm going to be expecting inside this. This is how I use it. I can pass it. And again, it is heavily script-based. You do need to kind of learn a little bit of coding to get started with this. But then the plan being, I build one script. I've got that hit of complexity once. And then hopefully, most of the time, I just reuse that same script. So an initial little spike of hard work, and then life suddenly becomes easy. And finally, I've got this little bit at the bottom. dbutils.notebook at exit allows me to pass some data back. So if I'm calling this from somewhere else, I can pass parameters in, and then I can build up a string and pass that back to whatever I called it. So I've got like that two-way call and response. Input parameters, do something, give me some output parameters. Tell me what happened. Now I'll show you the example of why that actually then makes sense when it comes together. So I've got this example. So validated venture works. So all those tables that I've just landed as CSVs in that first example, I can now say, well, actually, pick those CSVs up, try and apply each individual structure to it, separate that into those rows. So I've got a notebook. I've got my notebook activity. I'm pointing it at a specific Databricks cluster. So again, I can say, actually, run this on my big cluster, run this on my small cluster. I can be fairly flexible with it. I'm pointing it at a specific notebook. So you can see I had all my notebooks in there. I can go and browse and see what notebooks are deployed to Databricks currently. So I've associated it with a notebook, and I'm telling it that parameter. Except this time, like I did the first time, I'm passing a parameter into that parameter. So this Data Factory pipeline, I can call it several different times and give it different values. So I can just control this and say, Data Factory, run it for this table, then this table, then this table. And then guess what we can do? Same as we did in that first one. I can do a lookup and a for each. So I can say, actually, go to my configuration. Go to if I've got a config database that's just I'm using to orchestrate everything, so go get a list of tables I want to be working with, run my notebook for each of those tables. Which then, again, means if someone gives me a new data set, I can just add it to that list. I change the metadata. I add a record to a SQL database. I don't do a code deployment. Things are quicker. Things are much more agile. So if I just run this again, I can add a trigger. It's going to go through. It's going to run that notebook for however many times I've got my different files. I go and have a look. We're doing for time? Yeah, not too bad. OK, so you can see all those notebooks have kicked off. So again, I got my master one, kicked off all its child pipelines, passing it different parameters for each one. And that parameter that I've passed to each one gets passed down to that Databricks notebook. So it's doing different things depending on each point it runs. This is what we're thinking about when we're doing data engineering and ETL now. It's how can we be as flexible and dynamic and agile as possible? So if I dip down into one of these ones, it might have even finished by now. No, it's still going. I can go and have a look at it. I can say, what's actually happening? Oh, and I didn't start my cluster. So that's going to take 4 minutes, and then we can go and have a look at those results. So we'll crack on while that waits. And there is a trade-off. Because I'm using Databricks, because I don't want to have a cluster permanently turned on that I'm paying for, I let my cluster get turned off. There's a setting in my cluster saying auto-terminate. I tell it, if I've not used you for 15 minutes, just turn yourself off. And that's not me building a load of PowerShell, building a load of things to automate and work with it. That's just a setting on my cluster that will automatically shut it down. It means the next thing that tries to run has to wait for 4 or 5 minutes while that cluster starts up. And that used to be super painful in Azure. I'd have to do tons and tons of bits of PowerShell going, OK, here's a bit of PowerShell to start my thing. Wait until it's finished starting up. Now run a load of things. That's just baked in now. If Data Factory tries to run a Databricks notebook, the cluster's not turned on, it'll say, OK, I'll turn it on. As soon as it's on, it'll run through everything. So Databricks, in a nutshell, it is Spark as a service. It's Spark made easy. It's made by the guys who wrote Spark, so they kind of know what they're talking about. It's a hugely powerful transformation engine. So in the one example I was using, I've just got 2 VMs. There's just 2 servers running it. They're fairly small. It's fairly cheap. But I can scale this up. I can pay for more expensive VMs, and I can just keep scaling them out. I think the biggest one we've heard about was 6,000 nodes. It can go quite big. And that's the really nice thing. The configuration, the script for doing it on a few hundred metadata, and the script for doing it on a few petabytes of data is the same. I just need to change the thing underneath it that's running it. Suddenly, everything's a lot more flexible. OK, and you can use Python, Scala, R, and SQL. And C#'s coming. So it's really flexible in terms of the language. It's almost like pick the language that makes sense for you. And as long as you're using data frames, as long as you work within the most common libraries, there's no difference in all of those languages. With some caveats and exceptions. But mostly, if you want to pick Python because Python's easy and you've got some grads who know Python, you can, which is crazy. OK, so logic apps. What are these crazy logic app things? I like to think of it like this. A I've got a load of different services, and that's just a handful of the many that it provides. I'm saying, well, actually, if someone adds a new record to Salesforce, then write that to a SQL DB. If a build completes in Azure DevOps, then actually post it to Slack channel. It's that kind of thinking of there's something triggering it, then go do something else. So if I send a message, if something sends a message into a queue, check my metadata database, check what I should do with that, return a response, and then kick off my data factory. Suddenly, my data factories can be automatically triggered. And Logic Apps is that really lightweight little workflow thing. Now, very important, Logic Apps are not for moving vast amounts of data. They are small little messaging things. It's good for integrating. It'll scale out really effectively if you throw lots and lots of messages at it. But if you throw 100 mega data at it, it's going to start struggling. It is not something for doing big, chunky data transformation. That's not what it's for. But if you're doing small amounts of data, passing it back and forth is great. I mean, think of it like in SSIS, if you've got an object variable, you don't try and pass a massive data set into that object variable. You're going to have a bad time. So Logic Apps, small little bits of integration, decision-making, that's how it fits in for me. So let's have a bit of a look at Logic Apps. Do have a Logic App in here. OK, and again, heavily web-based. The designer is web-based. It all lives inside Azure. OK, so I'm just going to go in and edit this. And I've got a really, really simple Logic App in here. OK, it's got two things. When a blob is triggered or modified, so I've attached it to a blob store. It's constantly looking and monitoring that blob storage. So I've told it a container. I'm saying you're going into the landing. So it's watching a particular container in my Azure blob store. It's checking it every 3 minutes. And that's it. So I can just drag and drop. I want that container. Go and do that. I'll show you the kind of things I'm working with. If I want to add a new thing, I can add an action. And it comes up with a big list of here's all the different things I can do. So I can go and do things like text analytics. I can hook it up and work out sentiment on things that are going through. I can do things like trigger my Logic App every time there's a tweet with a certain hashtag, check the sentiment of it. If they were being nasty about me, send them a mean tweet back. I can automate my SARC on Twitter. There's loads and loads of flexibility that you can do. It can talk to lots of different things. So in this case, really easy. I'm saying when that blob is triggered, create a pipeline run. So I'm pointing it to my own storage. I'm pointing it at a particular data factory. So saying that inside that resource group, that particular data wrangler data factory, I'm picking which pipeline inside data factory to run. And then I've got that little bit of JSON to say, pass it the table name. So actually, on the outside of Logic Apps, you get these things. So each of these actions, so that blob activity, automatically pumps out a load of variables. I have to tell it this is how to understand the things. I get a choice of the name of the blob, the list of files. I can work with it quite easily. It pumps out data. So depending on the trigger you've picked, if you picked a Twitter trigger, it has the name of the user, the content of the text, the picture they had. If it's a SharePoint one, it has the list context. It has the name of the file, the metadata. So each action automatically just pushes out a load of parameters, a load of metadata that you can work with. So I'm just taking the file name. The only reason I've got a little bit of code there, I'm just stripping out the file extension. So this is a really, really simple triggering mechanism. It's just watching a particular container. If I land a file in there with a name, it'll run the pipeline for that name. So if I land something saying product category, it's going to run that particular data factory for my product category. So let's just do a quick example of that over here. So I've got Storage Explorer. This is how I'm going exploring my lake. This is my network browser, so I can go and see what's sitting inside my data lake. And I can go, you know what, I'm going to add a file. I'm going to pick the file to load. This isn't how I normally trigger things, by the way, just as an example of what you can do. So this could be someone's landing data, someone's sending me data, and then because they've sent it, this is how I'm triggering everything else. So if I then run and have my Logic App sitting watching that particular blob, I should see that in a moment, execute, and get the context of that file, and then run a load for that particular file. Possibly should have ran it before I actually loaded the thing, but it might actually check. Let's give it a second to make sure it goes through. But you can see, there we go. So now, in my logic app, I get the context. I can go and see, why did you trigger? What did you run? I can say, OK, it's picked up the fact it's that product category. So it knows that that file happened. So this is my trigger. This is my event watcher. And it's gone off. It said, I'm triggering my data factory, and I'm passing that in as my parameter. So if I go back over to my Wrangler, I can have a look again in my pipeline runs, and I should see right at the top, it's already run. There you go. A run for product category has already happened. So again, moving away from ETL windows, moving away from the idea that arbitrarily at midnight I'm going to start my data processing, because I'm using compute in Azure, because I'm entirely isolated from any actual on-prem compute. I'm not sharing a server with my OLTP system. I can actually just compute whenever I need to. As soon as I get data, I can start processing my data. I don't have to arbitrarily wait and do an ETL window just because that's how we always used to do it. So you can challenge a lot of the way that we used to work. So you can always see that my Databricks one's also now ran. So we have a look at what actually happens inside there. So my cluster must have started. It passed into my cluster, passed that file name. Again, I'm using the parameters. And then I should be able to see on the other side the output. So it's telling me how many rows it rejected, how many succeeded. I've got automated ETL. Again, it's not doing transformation for me. It's not going to magically know how to work out what a dim customer is. But a good chunk of what I normally spend a lot of time working with, that's no longer a problem. So I'm just reducing the amount that I need to customize on a data set by data set level. Useful? Good? Good. Thank you. We're not done yet. OK. So cracking on. So that's logic apps. Really small, lightweight little bits of integration. Something's happened, make a decision, call something else. Triggers and actions. OK. Again, repeated. For lightweight messaging only. OK. Huge array of connectors, can talk to lots and lots of different things. Many more things than Data Factory can, because it's all about looking at small amounts of data, not doing big data extracts. And I think it's really great for triggering data pipelines, for working out when things should run and reacting and having reactive data processing. I used to call it event-driven processing, but then the EDL is a massive right-wing thing in the UK, and that's a bad name to give things. So we moved on. Reactive data processing, I think, works. Kind of makes sense. OK, so finally, ADF mapping data flows. So this is fairly new. And yes, it is another thing called data flows. It's not the same thing as Power BI data flows or Power Platform data flows. I think they're now called different. So inside Data Factory, we've got these things called data flows. And what it is Databricks, but with a nice UI over the top of it. So if you were looking at that bit of Python and going, oh, God, I don't want to start writing Python. That's too codey. That's too deep. That's not for me. It looks like this. It looks like good old SSIS data flows, except when I hit execute on that, it runs on a Databricks cluster. It does it big at scale over memory. So it's a good, scalable, fast way of executing this stuff, but it's familiar. So this is kind of the modern, nice way of working with this stuff. When you click on it, you can get the list of actions, and it's like, I want to aggregate, I want to do a derived column, I want to do a split. They're suspiciously similar to what we used to call things. So again, it's not that massive a shift to start working with it, because it's built to be familiar. It's built to be the same kind of things that we work with. So again, it's building up a list of transformations. When you execute, it does have a bit of a startup time, because it has to start a Databricks cluster. It's provisioning Spark for you behind the scenes, but you never see the code. So it does something like that. So inside Data Factory, it's generating a Scala file. It's compiling it down to a Java executable, a jar file, and then pushing it into its own Databricks cluster. So that currently runs in its own one. It doesn't run on your Databricks cluster, so it's still going to take a while to execute because my one's turned on, the one in Data Factory is not. And actually, I've got two flavors of it. So the one I had a picture of, that's mapping data flows. There's one currently in preview called Wrangling data flows. What is that? It's Power Query. So if you're happy in like Power BI land, and you're building out extraction, you're writing M, you're using Power Query to bring data into it, currently in preview is the ability to do that inside Data Factory. Literally lift and shift the same M code, but it'll run on Spark. It'll run on Databricks. So if you've got a load of analysts who are going out and building their little ETL, that was really patronizing, you can then pull that out and then productionize it and make it scale. So those two are doing exactly the same thing. Mapping and wrangling, They're turning some instructions, turning it into a jar file, running it on Databricks. So if I've got my mapping data flow doing that kind of stuff, list of transactions, making a jar file, pushing it to Databricks, Wrangling is just the Power Query version of it. So if you're used to the web Power Query, it looks exactly the same, except you get to it through inside Data Factory. How are we doing for time? Yeah, not too bad. Okay. So if I'm back in Data Factory land, I can go in here. I've got this thing down the bottom. I've got this extra data flows bit. That's where I'm designing those transformations. So I've actually created several different data sets. And unlike the one I was using earlier, which was dynamic, and I used a parameter and it didn't have a schema, I've actually physically created these data sets pointing at, for this Parquet file, for this Parquet file. I'm attaching these ones to actual data sets. So I'm saying this is where to go and find it in the lake. This is the full path. I'm pointing it at the product table, which means it has a schema. So these are actual registered bits of data. So whilst my earlier bit, my automated bit, was super generic, super dynamic, the later bits, I'm saying I'm applying business logic. I can't really automate that too much. So I've got a few of those. I've got a parent pipeline. So I've got my main pipeline. And inside move and transform, I've got that data flow element. So this is saying I want to use data flows. I want to use a graphical thing which is going to run Spark for me. And inside there, I need to tell it which data flow to use. Again, I can use that to trigger the creation thing. I need to tell it which integration runtime to run on. So because this is Databricks baked inside of Data Factory, it needs to spin up its own cluster. It needs to know what that cluster looks like. So I can quickly create a new one, pick an Azure one. Then under this data flow runtime, it's going to ask, whoops, that's weird. I can tell it, how big should it be? How many cores should it be? How much money do I want to pay every time I run this? So you've got some flexibility in terms of deciding that. That's not quite as dynamic as some of the other stuff in Data Factory. Okay, and I can pass parameters into it, I can play around with it. So the main thing is data flows down here. So I'm on my data flow and I get this design surface. Again, it feels a lot like SSIS. So I can go and attach various different streams. I've got my different sources of data coming in. It's a little bit zoomed in. So I can see I'm pulling from product and then deciding which columns I want. So I'm dropping columns, I'm renaming things, I'm shaping it a little bit. I can have a derived column that's saying, actually, for some reason my ID came in as a string, change it so it's an integer. A normal kind of sum prep kind of things. And I'm doing lookups. Again, much like SSIS, I'm saying, I've got my product table, look at the product category. Now look at the product model. I'm building, essentially, a dimension. So if you want to have a visual way of looking at data transformation, a visual way of how you're building your various different bits of the warehouse, you can use this for it. So I've got my different streams coming in, just pointing at those different data sets and pulling it together. Now, there's some really advanced parts of this in terms I can allow it to have some schema drift. Because you know what? If the data types change slightly, if they get a few extra columns, don't break, just carry on going, do what you can. I can build some kind of protection into it. I can actually have parameters and wildcards actually push it through a lot. For me, generally, I use this when I'm doing that transformation bit. I don't do the cleaning, because cleaning, it's easier for me to have that one Databricks package. I've got a more powerful transformation engine in Databricks than I do in here currently. But again, this is in development. There's lots and lots of new features coming and pushing and pushing and pushing. And this actually came into general availability a few weeks ago. So you can go and use this. It is live and supported. OK, so that'll take a little while to run. So I'm just going to kick off. And then we'll look at some conclusions while that's going. OK. So again, a bit of a reminder there. It is low-code data transformations. It's actually got a lot of functions built into it. I can do regex. I can do lots of different derived things. I can have some very powerful calculations in there. But it's deliberately built to be accessible, to be fairly easy to get started with, to be really kind of easy to pick up. So your data analyst can look at it and go, OK, yeah, I kind of know what's going on here. Not quite as flexible as pure Databricks. I can't plug in lots of machine learning libraries. I can't use a whole plethora of different R libraries and Scala libraries and Python libraries. I can't just write massively recursive bits of code. But for doing that kind of shaping of data, super, super useful. Just remember that it is using Spark, so it will scale really, really well. So going back to the start when I was slightly mean about SSIS, it's kind of because against that checklist, against all those lists of things, I just don't find it performs as well as those other tools together. Now, I'm not saying that one of those tools individually fits all the box. There isn't now a one-stop shop that does everything in the world, although Data Factory is getting closer and closer. So my Data Factory itself, it is low dev effort fairly, because I build one thing, and then I reuse it massively. It is super flexible. Some things it can't do, which is why we rely then on Databricks behind it. But you can see with those patterns, with that look something up, dynamically decide what's going on, it is flexible and it is scalable. Suddenly, I can actually really, really much more quicker be able to kind of manage change. Databricks, it's definitely not low dev effort. You do have to write a bit of code. And yeah, you can write SQL, but you normally end up having to write a little bit of Python, a little bit of Scala or R, depending on your preference. But for me, it's an early spike at the start. Once you've built some of these really common packages, you can then just use it flexibly for lots of things and not have to go in and change it that much. So it's initial hard dev, and then actually not that much dev, depending on how you're using it. You can get really, really deep and build heavy, heavy applications. But it is massively scalable, massively flexible, super dynamic and parameter-driven. Logic apps, super low dev effort. It's really, really, it's deliberately built to be accessible to pretty much anyone. Not that scalable. Can't do lots of things. Don't throw massive data sets at it. But for doing that little integration, something's happened, kick off the next thing. Someone's landed an FTP, kick off the next bit. It's fantastic. And then mapping data flows, getting better, getting more features. And it is low dev effort, but it's not as parameterized as it could be yet. So that idea of saying, build once, use 100,000 times, it's not quite there yet. It's getting there. And when it's at that point, when it's at the point when I can actually just list a load of really generic transformations and say, apply this set of transformations to all these data sets, then it will truly be there in my eyes. So it's getting there, not quite there yet. So typical usage, this is the kind of thing that I'm building these days. So I've got a whole plethora of different data sources. I'm landing them in the lake because I don't want to have to deploy a schema, design a table, change a database. So I'm bringing data, landing it in the lake, picking it back up, doing some cleansing automatically, landing it back down again. Maybe picking it up and doing some shaping, transforming it into facts dimensions if I'm doing that kind of thing, and then pushing it into a warehouse. It's kind of the more modern data warehouse platform. So I'm using Data Factory to do that data acquisition because I can, it's nice, and it's easy, and it's scalable. I'm using Databricks to do that validation because as you saw, I can write automated data validation packages that make me happy inside. And then maybe so it's accessible to my business analysts, I'll be using mapping data flows to do that shaping, that assembling my actual business transformations, and then I use Data Factory to put it into a warehouse. So these different tools coming together in that data journey quite nicely. Those different steps, my Databricks, my mapping data flows, that's all orchestrated by Data Factory. And maybe if I want it to be really, really, really dynamic, really data, like event-driven, then I have logic apps triggering those things. That's kind of the new combination of different tools that just unlocks so much more potential. So the kind of architectures we're talking about these days are a hell of a lot more complicated than they used to be. It's no longer just a picture with a single SQL server in it. If you're working in the cloud, you are stitching together the best of lots of different tools. It does become more complicated to achieve these things. But then it's not that much more complicated. These things are built to talk quite nicely to each other. And if we're talking about SQL Server, actually, realistically, integration services, reporting services, analysis services, they're all just different tools. They just happen to come bundled under one install. So we're dealing with lots of different things here, but they're all very specialized for doing their various different things. So we're pulling data into a lake. We're doing some data processing. We're pushing it out into a warehouse. So actually, hopefully, we should have a mapping data flow that's run. Let's go and see. No, it's still in progress. Boo. So that'll be starting up that Databricks cluster, so I can't go in and show you the results of that. I should have run it recently. Let's go and see. Do I have Great Dim product in there? There we go. Oh, right at the bottom. So once it's run, it's spun up that Spark cluster. I can then go say, well, what actually happened inside there? And I get my full history. I've got all my results that's going on. So I can go and step through and say, well, actually, what happened? How many rows were there? I've got this nice idea. In through all my transformations, what was happening then? If I was filtering out, I can get a nice, actual, auditable history of all the stuff going on. That just happens automatically as a result of it. When I'm writing out data, I can see how many rows I wrote out, how long it took. So mapping data flow is really, really good for that kind of easy management of that stuff. OK, cool. So that is everything I had to go through. Again, session evaluations, super, super useful. Don't forget that the credentials, the certifications are out there. So if you want to become a data engineer, if you want to get into this kind of thing, the credentials are a really good way to start. That certification actually will kind of makes you read into a lot of these stuff, gives you that chance to practice, make sure you've covered these bases. So hopefully, you're now all inspired to be a data engineer and stop writing SSIS. Thank you.